Friends, welcome to my YouTube channels. Today our topic is composite bar solutions. This belongs to unit 1 in strength of material. So composite bar, what is the questions given here? A compound tube consists of a steel tube. In middle this is steel tube. This dia is given, inner dia 140 mm and external dia given 160 mm. External dia given 160 mm for the steel bar. Then that is brass bar inserted. So how much the internal dia for the brass bar? Same as a 160 mm, which is the external dia of the steel, and external dia of the brass is 180 mm. They given. So composite bar means this all rigidly fixed, all the bars rigidly fixed each other. So the compound tube carries the axial load that carry 900 kilonewton. What they are asking? Find the stresses and load carried by the each bar and also amount of shorten. So how much reductions of the length they are asking. So length of the each tube, because compound bar, so length of the each tube will be 140 mm and given is steel Young modulus and brass Young modulus given. So we have to find out the three things. First stresses and load carried each bar and reductions of the length. So first inner dia, external dia, already I wrote here. So symbols I taken: inner dia, DIS steel, DOS outer dia of the steel, and DIB brass inner dia, DO brass outer dia I taken. So we'll find the area first, the each steel bar and brass. So this is the hollow tube. Hollow tube, now what will be the area here? So I am going to write the formula here. Area of first steel bar. So symbols will take AS. So what is the formula? Because suppose bar means cross sections, circular cross sections, pi by 4 d square. If hollow cylinder will be there, na, pi by 4 d0 square minus di square. This is the hollow. So here already you are seeing internal and external dia either. So what is the area? This will write. What will write? Pi by 4 d0, this is called steel whole square, minus di steel whole square will be the area of the steel bar. Then we will substitute the value here. What is the value here? Pi by 4 160 external dia. So 160 whole square minus 140 whole square. So this value already we calculated, we kept ready. So 4712.4 mm square. This is the area we got it. So okay, now area of the brass bar. Area of the brass bar they given. Outer brass bar. Okay, so area of brass bar. That symbols we are taking brass AB. That symbols I am taking AB. So same, this also hollow bar na. What will write here? Pi by 4 D0B whole square minus inner dia B whole square. So we can write like this. Okay. So we will now substitute the value here. What will be the value here? See this. Pi by 4 180 mm given here. 180 mm minus 160 whole square. So this value will come. Already we calculated this also, 5340.7. 5340.7 area unit is mm square. So area we calculated. Now we have to calculate the stresses. So what is the conditions? Suppose composite bar problem will be there. What will be the conditions here? So two conditions will be there. Always. Strain of the steel will be equal to the strain of the brass. This conditions number 1. What is conditions number 2? Load carriage. For the, what is the given here? Load carried by the 900. So the compound tube carry the axial load 900 Newton. So that 900 Newton kilonewton will be equal to both load, steel and brass. So PS plus we can write PB. This will be the two conditions where based on these two conditions we can solve the other unknowns value. So first, what is stresses? Stresses on the, where they are asking, find the stresses of the bar carry, stresses of the steel bar. So see here, stress. So suppose Young modulus will be, what is, or you find the strength. Now conditions 1 you apply first. So apply the conditions 1. Conditions 1. What conditions were they given? Strength of the steel bar equal to strength of the brass bar. So if you will see here, stress equal to strength. You see here this formula. Young modulus equal to stress by strength. So strength equal to what we can write? Strength equal to, we can write stress by Young modulus. Now what we'll write here? Strength of the steel bar. So strength of the steel bar is nothing but stress of the steel bar, and Young modulus is given for the steel bar, equal to brass by E brass. So this we wrote here. Now we'll substitute the value. We'll get some relations here. So what is the value for the stress steel bar? We don't know. Equal to, we can write ES by EB. We can write ES by EB. So ES will go there. ES by EB into brass, stress of the brass. So we can write here ES 2 into 10 power 5 divided by 1 into 10 power 5 into brass. So 2 times this will get cancelled, so it will come brass bar relations will be 2 steel bar, steel relations 2 into brass. This is the relations we got it here. So this is the relations we got here. Now we'll apply the second conditions. What is the conditions 2? Conditions 2 we know P, that means total load carried how much? 900 kilonewton. So 10 power 3 equal to PS. PS is steel, pressure of steel, pressure of brass. Now we'll write this formula here. So 900 into 10 power 3 equal to PS. So here what we'll write here? You know the stress equal to internal force per unit area. Stress is equal to internal force per unit area. So P is equal to what we can write here? Stress into area. So for steel na, what we write? Steel into area of the steel plus brass means stress of the brass into area of the brass. We wrote here. This two formula we wrote. Now what we'll do? We'll substitute the value here. Now we'll substitute the value. So what we'll get here? 900 here. Already this loading the, then stress sigma S. What is 2 sigma B we got here? 2 sigma. Sigma S how much we got? 2 sigma B. Area of the S steel bar. So 4712.4 into plus this part I am going to rub it here. So now what will be that? Sigma B as it is. Then sigma B in a brass. Now area of this brass, where area of the brass? 5340.7. So we got this. Now if we'll solve this, 2 into this and this also brass, this also brass, it will come 1 terms will come. So we can write here sigma B is equal to 900 into 10 power 3, and this value, if we will solve it, this into this plus this, it will come, this value already we calculated, 14765 point something is that 14765.5. 5. So this way we'll get the stress of the brass. So this is coming 50 point something, I think so, 60.95, 60.95 kilonewton per mm square, because its stress unit is kilonewton per mm square. So we got now. Now steel, how we'll get this steel? Already we saw here this relation from here. What is the steel? Stress of the steel bar? 2 into 60.95, it will come 129 Newton per mm square. We got the stresses of the each bar. So this is the stress of the brass, this is stress of the steel we got. So 1 over. Now they are asking what is load carriage of the each bar. We have to calculate the load. So now we'll go this, I will review this problem. So we have to load carriage, then shortens. This we have to shortens means what is the reductions of the length. So these two we have to unknown, we have to find out. Okay. So let us here, we'll write again. So load carriage first we'll find out. So load carriage will find out what is that. So load carriage by the brass tube. Of the brass tube. So what will be the formula? If you like load brass tube now, so PB equal to sigma B into AB. Sigma B into AB, will get this. So what is the sigma B here? 60.95 into A brass. A brass how much here? This is the brass now. 5340.7. So if we'll calculate here, we'll get the load carriage of the brass tube. So this value will come 325.52 kilonewton. 52 kilonewton. So you have to calculate from the calculator. So this we know. Now load carriage of the steel bar, steel tube, PS. So how we can write? You can calculate also this way. Stress of the steel into area of the steel. But another method also what is? Total what is the load carriage here? 900 kilonewton. Then minus 325.52 kilonewton. This way I also you calculate. So this will come, I think 485 kilonewton. So getting 485 kilonewton. So because already total load carried 900. So brass load already we calculated. So still calculate, subtract, or another way, sigma steel into area of the steel, you will calculate, you will get the same thing. So okay. Now final part what is? Shortens of the length. That means reductions of the length we have to write. So what is the reductions of the length or decrease in the length? You can write decrease in the length. Decrease in the length. So already you know delta L, PL by AE. PL by AE. Now we can write P by A nothing but stress into length by E. Now if you want to decrease in length will be equal. Either steel or brass, both will be decrease in length will be equal. So any one value we can find out. So here we are considering okay, steel or brass, whatever you want. So this will be, you write here steel or brass, anything. So I am writing okay, steel. Then length will be 140 and area of the steel. Area of this. Okay, this also write now length. Now write the value. Stress of the steel were 121.9 divided by young modulus of the steel. Young modulus of the steel somewhere either 2 into. So 2 into 10 power 5 into length 140. Into length 140. So suppose you want to write sigma B EB by L, same answer will come, because decrease in length will be, because this is compound bar. So decrease in length will be, both will be same, either steel or brass bar. So this value will come for you 0.0853. 0.0853 mm. So this like this will getting the answer. Okay. So compound bar problems will be there now. They will ask only what is the stress, what is the load, what is the decrease in length or shorten in the length. So this way we can simply stress, we can solve these questions and all. Okay. So okay, students, watch this video till end, beginning to it. Then only you will understand the contents, and subscribe the channel. Those still not subscribe the channel, subscribe the channel. So for that you will get the motivation, and I will bring the new problems for you. Okay, and share this all content to your friends. Okay, thank you, students.